You ever stop and think about the apps you use every single day, how they actually get made? It can feel a little like magic, right? But it all starts with a simple idea. So today, we're going to pull back the curtain and break down that entire journey, from just a thought in someone's head to a finished piece of software on your screen.
So yeah, how does that happen? How do we go from that spark of inspiration to a real working app that you can tap and swipe and use? Well, it's not some kind of sorcery, I promise. It's actually a really logical journey that always starts with a simple, powerful plan.
And that's the very first step. Before anyone even thinks about writing a single line of code, you have to create that plan. In the world of programming, we call that plan an algorithm. You can think of it as the blueprint or the recipe. It's the core logic for everything that comes after.
Now, what's really important to get here is that an algorithm is not computer code. Not at all. It's a set of instructions written for a human in plain English. It has to be crystal clear, with a definite start and a definite end. It's basically you explaining the what and the how of your idea before a computer ever gets involved.
And an algorithm can be incredibly simple. I mean, look at this. It's really just a recipe, laying out the 6 basic steps to add 2 numbers. Step 1, start. Step 2, get a number. You get the idea. It's straightforward, logical, and anyone can read and understand it. This is the foundation.
But you know, reading a list of steps is one thing. What if you could actually see the logic, see how it all connects and flows? Well, that's exactly what flowcharts are for. They take our step-by-step plan and turn it into a visual map. Flowcharts have their own visual language made up of standard symbols, so everyone's on the same page. The ovals are easy. They just mean start or stop. The parallelograms, those slanted boxes, are for any kind of input or output, like getting data from a user or displaying a result. The plain rectangles are where the work gets done. That's a process, like a calculation. And that diamond? That's for making a choice, asking a yes or no question.
All right, so let's put those symbols to work. Here's that exact same plan for adding 2 numbers, but now it's a flowchart. You can literally follow the arrows from the start oval, see the input steps, watch the sum happen in the process box, see the result get printed, and finally arrive at the stop oval. Same logic, just in a visual format that's super easy to follow.
Okay, this is great. We have our plan, maybe even a nice diagram for it. But how do we actually tell a computer what to do? You can't just hand it a drawing and expect it to get to work, right? We need to translate our human logic into a format the machine can understand and execute. And for that, we need a language.
A programming language is that essential bridge. It's like any other language, except it's incredibly strict. It has its own precise grammar, which is called syntax, and a specific vocabulary. The whole point is to write our instructions so perfectly that there's absolutely zero room for confusion. The computer knows exactly what to do.
And just like you wouldn't use a hammer for every job in a workshop, there isn't just one programming language. The one you pick totally depends on what you want to build. Making a cool interactive website, you might use JavaScript. Building an iPhone app, Swift is probably your go-to. Developing a video game, you might use C#. Each one is a specialized tool for a different kind of job.
Now this brings us to something that trips a lot of people up. We often hear the words code and program thrown around like they mean the same thing, but they're not. They are 2 very distinct stages in this whole creation process. So here's the simple difference. Code is the stuff a programmer writes. It's the text file full of instructions written in a programming language. The program, on the other hand, is the final executable file that the computer actually runs. The easiest way to think about it is this. Code is the recipe, and the program is the finished cake you can actually eat.
Let's look at a real example. This right here, this is code. It's written in the C programming language. A human programmer can read this and understand, okay, this is for calculating a GPA. But your computer can't run this text file directly. It's just a set of instructions.
And this is the program. After that code gets translated, this is what you get. An actual application that runs, asks you for input, and gives you a result. It's the thing that does the job. You go from the written instructions, the code, to the final working tool, the program.
So, let's do a quick recap. We've talked about algorithms, languages, code, and programs. So where does the word software fit into all of this? For that, we need to zoom out a little and look at the big picture.
Software is, well, it's the whole package. It's usually not just a single program. It's often a collection of programs, plus all the data they need to run, and any documentation like help files or user manuals. It's the complete, polished, user-ready product.
This house-building analogy ties it all together perfectly.
The algorithm is the architect's blueprint. The programming language is like the local building codes you have to follow. The code itself is the detailed work order for the crew. A tool called a compiler, which does the translating, is the general contractor. A finished program is like one system in the house, like the plumbing. And the software, that's the entire finished house, keys in hand, ready for you to move in.
A perfect example is something like Microsoft Office or Google Workspace. You don't just get one thing called Office, right? You get Word, Excel, PowerPoint, a whole bunch of individual programs. These are called software suites. That entire collection, designed to work together, that's the software.
So there it is. We've gone all the way from a simple idea to a logical plan, to the code, to a program, and finally to a complete piece of software. It's an incredibly powerful process for turning thoughts into real, usable tools. Which kind of leaves just one final question for you to think about. Now that you know the blueprint, what would you build?